Hello everyone. In this lecture we are going to discuss class 9th topic, chapter number 7, statistics, practice set 7.5. So within a practice set 7.5 we have the first question. Yield of soybean per acres in quintal in Mukund's field for 7 years was 10, 7, 5, 3, 9, 6, 9 quintals. Find the mean of yield per acres. So that we have to find here the mean for the given observations. So we have, for finding the mean for discrete data, the formula is like way, mean to be equals to sum of all observations divided by total number of observations. So that sum of all observations means we have to add up whatever be the quintal quantity we have given for 7 years in the Mukund's field. So that we have now the 10 plus 7 plus 5 plus 3 plus 9 plus 6 plus 9 whole divided by, we have total observation 1, 2, 3, 4, 5, 6 and 7. So divided by 7. So 10 plus 7 plus 5 plus 3 plus 9 plus 6 plus 9, we have a 49. 49 divided by 7, we are getting a 7. So that mean value we have a 7. So how to write now our final answer? The mean of yield per acres is equal to, we have a 7 quintal, because given observations in terms of the unit quintal, so that we have the mean of yield per acre, that is equals to 7 quintal. Look at the question number 2 from practice set 7.5. Find the median of the observations 59, 75, 68, 70, 74, 75, 80. So for finding the median, first of all try to note down the given observations is in the ascending order. So that ascending order of given observation we have is of the form 59, then 68, then we have 70, then we have 74, then we have 72 times, and at last we have the 80. So now the total number of observations we have exactly the 7. 7 becomes an odd number, so it is easy to find the middle value of the given observation, or we might be says the middle observation. So leave 3 observations towards left, leave 3 observations towards right, so that the middle observation we have is 74. So that we have now the median to be equals to the middle observation. So the middle observation we have 74. So the median for the given data we have a 74. Look at the question number 3 from practice set 7.5. The marks out of 100 obtained by 7 students in the mathematics examination are given below. Find the mode of these marks. We have the marks out of 100 for 7 students respectively 99, 100, 95, 100, 100, 60 and 90. So for finding the mode, first of all arrange the given observation in terms of ascending order, so that we are having the ascending order of given observation is of the form. We have least number is 60, next to it 90, next we have the 95, next to it 99, next to it 100, then 100 and last one again 100. So 100 is repeated here 3 times. So total observations now we are having 1, 2, 3, 4, 5, 6, 7. So 7 students total. So our ascending order is correct now. Now keep in mind for finding the mode, we well known mode becomes the maximum number of times repeated observation. Now check which observation is repeated maximum number of times. So here 60 exactly once we are having, next to it 90 is only once, 95 once, 99 is once, but 100 repeated 3 times. So maximum number of times Repeated observation we have 100. So mode of the given data we have 100. Now look at the fourth sub question from practice set 7.5. The monthly salaries in rupees of 30 workers in a factory are given below, like 5,000, 7,000, 3,000 rupees and so on till the 6,000, 4,000 rupees. From the above data, find the mean of monthly salary. So that we are preparing the table. First column stands for the monthly salary. In rupees we have given. That means those are the XI values. So we have mean monthly salary is, or the least monthly salary is the 3,000. So 3,000. Next to it we have the 4,000. Next to it 5,000. Then 6,000. Then 7,000. Then 8,000. And maximum salary we have the 9,000 rupees monthly. Now we are preparing the next column for the number of workers. Those who are having their monthly salary becomes 3,000, 4,000 and so on rupees respectively. That means we have here the next column for the FI means the frequency of 3,000, 4,000, 5,000 and so on. Now check how many times the 3,000 is repeated. So that we are having 1, 2, 3, 4, next line 5, then 6, then 7, exactly 7 and one more we have the 8 times. That means here 8 number of workers, those who are having their monthly salary 3,000 rupees. Now for the next one 4,000. Find the number of workers whose monthly salary becomes, we have 4,000 rupees. So we are crossed out now the 4,000. 1, 2, 3, then 4, 5, 6, then 7. So exactly 7 workers we are having whose monthly salary 4,000 rupees. Now crossed out the 5,000. 1, then 2, 3, then 4, 5. That's it. So we have exactly the 5 workers whose monthly salary is 5,000 rupees. Now 6,000. Find the number of workers whose monthly salary is rupees 6,000. So crossed out the 6,000 now. 1, 2, 3, 4. So exactly 4 times we have the 6,000. Now crossed out the 7,000. We have 1, then 2 and 3. Exactly 3 times be the 7,000. Now crossed out the 8,000. We have 1, then next to it 2 times 8,000 and 9,000 we have exactly 1 time. Now let's add up the frequencies means the FI values. We have those are ultimately the F1, F2, F3, F4, F5, F6 and F7 values. And those are X1, X2, X3, X4, X5, X6 and X7 values. Let us try to add up now the F1 plus F2 plus F3 and so on. So that 8 plus 7 we have 15, 15 plus 5 20, 20 plus 4 24 plus 5 we have 29 plus 1 is 30. So that means total frequency is denoted by capital N or sum of Fi, that is equals to we have a 30. Now to evaluate the mean, we have mean is denoted by the x bar and the formula we have is the sum of xi Fi divided by sum of Fi. That means let's try to prepare the next column for sum of xi Fi we required. So the next column for xi Fi. That means x1 into f1. So let us try to analyze the given data. Means we are having, there are the 8 workers whose monthly salary we have 3,000 rupees. That means once a one worker having monthly salary is 3,000 rupees. So such a 8 workers we are having. So 8 workers are monthly salary. We have x1 into f1. 8 3s are 24 on it. We have 3 zeros. That means 24,000. Same thing. Each worker having monthly salary 4,000. Such a 7 workers we have. 7 4s are 28. So that we are getting 28,000. 5 5s are 25 and so on. 25,000. 6 4s are 24,000. Now 7 3s are 21. so that 21,000, then 8 2s are 16, so that 16,000, and at last 9,000 into 1 we have 9,000. Try to add up now so that we are getting the value for sum of XIFI, that is we are having 1,47,000. Now to evaluate the mean, so 1,47,000 be the monthly salary of all three workers, so that on an average we are evaluating, that means 1,47,000 divided by 30, 10 from numerator denominator getting cancelled, 3 4s are we have a 12, remainder is 2 generates 27, 3 9s are 27, so that we have 4,900 rupees. So mean monthly salary of worker is equals to 4,900 rupees. Look ahead for the question number 5 from practice set 7.5. In a basket there are 10 tomatoes. The weight of each of these tomatoes in grams is as follows. We have given 60 gram, 70 gram, 90 gram, 95 gram, 50 gram, 65 gram, 70 gram, 80 gram, 85 gram, 95 gram. Find the median of the weights of the tomatoes. So that we have given the discrete data here, that means the individual observations only. So try to arrange the given observation in terms of ascending order. So ascending order of given observation we have 50, 60, then we might have the 65, then we have a 70, 72 times. After that we have a 80, then 85, then 90, then 95 2 times. So that here once count down the total number of observations, we have n to be equals to 10. So since here total number of observation is an even number because 10 is an even, so that to evaluate now the median, we have median to be equals to the average of middle observations. So let us try to evaluate that the middle observations first. We have leave 4 towards right, 4 towards left, so 70 and 80 are the middle observation. Take their average, means 70 plus 80 divided by 2. So that 70 plus 80 we have 150, 150 divided by 2 exactly 75. So median of the given data we have a 75. Now all observations are given in terms of the gram, so that we are writing our final answer, that is median unit we have in terms of the grams. So final answer we can write now, the median of the weight of tomatoes we have 75 grams. Now look ahead for the question number 6 from practice set 7.5. A hockey player has scored the following number of goals in 9 matches: 5, 4, 0, 2, 2, 4, 4, 3, 3. Those are the scores in the matches. Find the mean, median and the mode of the data. So now once we have given the observations, I am arranging that given observations means the scores of goals in 9 matches is in the ascending order. So that we are having 0, 2 is repeated twice, then 3 is repeated twice, then 4 is repeated 3 times, and we have 5 only once. Now for finding the mean, we have the formula sum of all observations means sum of xi divided by total number of observations means we have the n. So sum of all observation means 0 plus 2 plus 2 plus 3 plus 3 plus 4 plus 4 plus 4 and plus 5 whole divided by total number of observations means the total number of matches. Ultimately we have a 9. Exactly 9 scores we have given here. So now let us try to add up them. We are getting 27 divided by 9 becomes the 3. So mean score of a particular player we have a 3. Now to evaluate the median. Median is nothing but the midway observation. I am writing the middle observation. So that look at once we have total number of observations are 9. So the middle observation, leave 4 towards left and leave 4 towards right. So the middle observation we have a 3. So median score of a hockey player is equal to we have a 3. Now for finding the mode, mode is nothing but the maximum number of times repeated observation. Now check which observation is repeated maximum number of times. So that here 2 is repeated 2 times. I am writing at the bottom of the given observation. 3 is repeated 2 times and 4 is repeated here 3 times. So maximum number of times repeated observation we have a 4. So mode of score of a hockey player is equal to we have a 4. Look at the question number 7 from practice set 7.5. The calculated mean of 50 observations was 80. So that simultaneously I am writing the given data. We have 50 observations, means the total number of observation means we have the value of n is 50, and the mean becomes we have a 80. So that mean is denoted by x bar. We have a 80. It was later discovered that observation 19 was recorded by mistake as a 91. What was the correct mean? So that once we are having the formula for evaluating the mean is nothing but sum of xi divided by n. So mean we have given the 80, that is equals to sum of xi divided by n value we have a 50. So that should implies now the sum of xi, after all shifting 50 from RHS to LHS, we are getting 80 into 50. So that value of sum of xi we are having 80 into 40 becomes 4000. Now by mistake we recorded 91 instead of the 19. So that in case of the 4000 we can't require that the 91, by mistakenly we recorded, but we required the 19. So that 4000 minus of 91 plus 19, we are getting now the value becomes 3928. So this 3928 is nothing but new sum of xi values, that is sum of scores, or we might be says the observation is equal to we have 3928. Now once we replace the observation 91 by 19, so the total number of observations are constant, that is equals to 50. So now the new mean we are getting. The new mean is equal to, we have the new sum of xi divided by the total number of observation n. So the new mean value now we are having is of the form new sum of xi we have, after all replacing 91 by 19, 3928 divided by total number of observations we have 50. So that 3928 divided by 50, we are getting new mean to be equals to is 78.56. So ultimately new means what? The correct mean. So correct mean we have now 78.56. Look at the question number 8 from practice set 7.5. Following 10 observations are arranged in ascending order as follows. So already observations are arranged in the ascending order. Total number of observations we have a 10. 2, 3, 5, 9, x plus 1, x plus 3, 14, 16, 19, 20. If median of the data is 11, find the value of x. Now once we have the total number of observation 10 that are even in number, so that the median of the given data is the average of middle observations. So let us try to evaluate at start the middle observations. Total 10 we have in number, so leave 4 towards right, leave 4 towards left. So the middle observations we are having x plus 1 and x plus 3. Their average is given by x plus 1 plus x plus 3 divided by 2. And the median value already we have given for the data, that is 11. So once we shift the 2, so we are getting 11 into 2, that is equals to, now x plus x becomes the 2x and 1 plus 3 becomes the 4. So we are getting here linear equation in one variable. That is, we can interchange the LHS and RHS. We can write it is of the form 2x plus 4 equals to 11 2s are, we have a 22. Once we will shift the 4 from LHS to RHS, so plus 4 becomes now the minus 4. 22 minus of 4, we have the 18. So the value of 2x is equal to, we have 18. We require to evaluate the value of x. So we can't require to shift that to 2 is a multiplier. After all shifting, it will become a divisor to 18. 2 1s are 2, 2 9s are, we have 18. So the value of x becomes, we have a 9. Look at the question number 9 from practice set 7.5. The mean of 35 observations is 20, out of which mean of first 18 observations is 15 and mean of last 18 observations is 25. Find the 18th observation. So that at start we have given the total number of observations. I would like to assume it as a n1. We have 35 observations we have, and whose mean we are assuming as a x1 bar. That is equals to, we have a 20. Among them, now which are the first 18 observations? That are x1, x2, x3, still the x18. So whose mean we have given a 15. So that I am assuming now n2 means the first 18 observation, and whose mean by x2 bar we have given a 15. Now among the 35 observation, which are the last 18 observation? That are x18, x19, x20, so on till the x35. That means now we have again the total number of observations. I am assuming it by the n3, that is 18. That means the last 18 observations we have, and whose mean, that means I am assuming it by x3 bar, we have given 25. So that for the first case, total number of observation we have 35 and whose mean we have the 20. So that as per the formula now, we have the x bar to be equals to sum of xi divided by, we have total number of observation. Where here I goes from 1 to 35 because we have total observations are 35. So that's the value of x1 bar. So I am writing x1 bar to be equals to sum of x1 I bar, x1 I divided by, we have a n. N means now the n1. So x1 bar value we have given the 20. Sum of x1 I as it is, that value we have to evaluate. Sum of x1 I for the first case, that's why we are assuming it as x1, and divided by n1 value we have given the 35. So that sum of, that means total 35 observations, that is x1 I, we are getting, after all shifting the 35 into 20, we have 35 2s are 70, so that we are getting 700. Now as per the second case, we have given first 18 observation whose mean, that is denoted by the x2, that is 15. So that now we are having the formula for evaluating the mean, x2 bar. So for the second case, we are assuming now sum of x2i, where I goes from 1 to 18 here, first 18 observations we are having, divided by n2. So that should implies now sum of first 18 observations we are having. Let's try to shift now the n2 value, or we are replacing firstly by the value x2 bar we have given the 15, that is equals to the sum of first 18 observation, means I goes from 1 to 18, divided by, we have the total number of observation, that is 18. So try to shift now the 18 from RHS to LHS, so that we are getting sum of first 18 observation are of the form 15 into 18, we have 270. Now look at the third case. In the third case, we have now last 18 observations among the 35 observations. That means x18, x19, x20, so on still the x35. So that we have to prepare the formula for finding the mean of last 18 observation. x3 bar to be equals to sum of now last 18 observation, means now I is running from 80 to 35, divided by total number of observations we have a 18. So the x3 bar value we have a 25, that is equals to sum of last 18 observation, that means I running from 18 to 35, divided by we have 18 observations. So try to shift now the 18 from RHS to LHS so that we are getting sum of last 18 observations, that is equals to we are having 25 into 18, we are getting 450. Now look at those two summations. We are calling them as a equation 1, 2 and 3. So look at the equation 2 and 3. 18 is repeated twice. That means once we add up the sum of first 18 observation, that means I running from 1 to 18, and sum of last 18 observation, means I running from 18 to 35, and once we subtract one of the x18 value, so that should equals to the sum of all observations, that means I running from 1 to 35, because here 18 is repeated twice. So one time 18 is added and one time 18 is subtracted. That means we have to subtract here x minus 18. Look at here, already I wrote the observations. Once we add up now those two cases, that means sum of first 18 and sum of last 18. 18 is repeated twice. We required the 18 once only. We can't require twice. So let's try to subtract one of the x18 from sum of all observations, means from 1 to 35. That is x1 plus x2 plus x3 plus so on up to plus x35. So that now we are having the values for x2 I running from 1 to 18, means first 18 observations are addition, we have 270 as per the equation number 2. As per the equation number 3, last 18 observations are sum, we have 450, and minus of x18, that is equals to now we are having sum of all observations, that is equals to 700. Now 270 plus 450, we are getting 720, minus of 700, we are shifting the 700 simultaneously, and x18 from RHS to LHS, LHS to RHS. So 700 becomes now the minus 700, and minus x18 becomes now positive x18. So the 18th observation means x18 value we have 720 minus 700 becomes a 20. So the 18th observation we have a 20. Look at the question number 10 from practice set 7.5. The mean of 5 observation is 50. So that we have given now the total number of observation is denoted by n, that are 5 observations, and whose mean is denoted by the x bar, we have a 50. One of the observation was removed from the data. So once we removed one observation, means total number of observation, now I am assuming it as a n1. 5 minus 1 becomes a 4. Hence the mean become 45. So for that we have the value of mean, I will assume that it as a x1 bar, we have a 45. Find the observation which was removed. So now I am assuming let x be the observation which was removed. That means now once we are having the formula for evaluating the x bar is a sum of xi divided by n, means the total number of observation. So the value of x bar at start we have given a 50, sum of xi as it is, and now the total number of observation for them we have a 5. So what is the value of sum of xi? That means sum of all observation, we have a 50 into 5 becomes 250. Now in case of sum of xi, here I varies from 1 to 5 because we have given total 5 observation. Now we have to remove one observation among the 5. We assumed it as a x, so that now we are having sum of xi and minus of one observation, that is x is removed, that is equals to we have now sum of xi we have 250, and among that we have to remove one observation, that is x. So that will becomes now new sum of xi, and we have given once we removed one observation the mean becomes 45. That means now I am writing we have the x2 bar to be equals to sum of xi, but at this time we have to take the new sum of xi after all reducing or the removing one observation, divided by total number of observations we have the n2. So the x2 bar value, or we may assume the x1 and n1. So here instead of the 2 and 2 I am taking x1 bar and n1. So x1 bar value we have the 45, that is equals to new sum of xi we have 250 minus of x and divided by, now the n1 value we have 4 because we have to remove one observation. Try to shift the 4. 45 into 4 we are getting 180, that is equals to 250 minus of x. So it is the linear equation in one variable. Try to evaluate the value of x, means the removed observation, so that we are interchanging or we are shifting directly minus x from RHS to LHS and 180 from LHS to RHS, so that now we have x to be equals to 250 minus of 180. So the value of x we are getting exactly as 70. So which observation is removed? That is 70. So 70 was removed from the given observation. Then we have the mean of the 4 observations now, that is 45. Look at the question number 11 from practice set 7.5. There are 40 students in a class. Out of them 15 are the boys. The mean of marks obtained by boys is 33 and that of for girls is 35. Find out the mean of all students in the class. So look at here, we have total number of students becomes the 40. Among them we have 15 are the boys, so that means the remaining are the girls. So remaining means the 40 minus 15, we have 25 are the number of girls. So let us assume that mean marks by boys we have x bar, that is equals to, we have given the 33, and mean marks for the girls we have y bar, let it be a 35. So what is the formulation for evaluating the value of mean? We have x bar to be equals to sum of xi divided by n. N means now here total number of boys, so I am assuming it as a n1, and the total number of girls becomes the n2. What is the value of y bar? That will becomes, now instead of the x we are writing the y, so y bar to be equals to sum of yi divided by n2. So now we have given the x bar value becomes the 33. So 33 to be equals to sum of xi as it is. That means sum of scores by 15 boys divided by, we have the total number of boys 15. Once we shift the 15, so that we have now the 33 into 15, that is equals to sum of xi. So sum of xi to be equals to 33 into 15, we have 495. So what is mean by the sum of xi? Sum of score of marks by boys. Okay, now let us try to find the value for sum of scores of marks by girls. That means the sum of yi. So we have given the y bar value as a 35, that is equals to sum of yi as it is divided by total number of girls, means the n2 value we have the 25. Once we shift the 25, so that we have now the 35 into 25, that is equals to sum of yi. So the value of sum of yi we are having here 35 into 25, 875. Now sum of scores in all, that means including boys as well as the girls. That means sum of score of marks in all, keep in mind, that is equals to sum of xi plus sum of yi. That will be 495 plus 875. So that addition of them we have now 1370. So we have to evaluate here mean marks of all students. So how could we evaluate now the mean marks of all students? Sum of scores of marks of all students Here you may have of all students. We have it is 1370 and total number of students including boys and girls we have the 40. 10 getting cancelled. 137 divided by 4 we are getting 34.25. So mean marks of all students we have 34.25. Look at the question number 12 from practice set 7.5. The weight of 10 students in kg are given below. 40, 35 kg, 42 kg, 43 kg, 37 kg, 35 kg, 37 kg, 37 kg, 42 kg and 37 kg. Find the mode of the data. So for finding the mode, first of all I am rearranging the data in terms of ascending order. So the ascending order of weight of 10 students in kg, we have it is of the form 35 is repeated twice, so 35, 35. 37 is repeated 4 times, so 37, 37, 37, 37. Then 40 once only, 42 twice again, and the last we have the 43. So we have to evaluate now the mode of the data. How to evaluate the mode? Mode is nothing but maximum number of times repeated observation. So check which observation is repeated maximum number of times. Here 35 I am writing at the bottom 2 times, 37 4 times, 40 is 1 time, 42 is 2 times. So among them which observation is repeated maximum number of times? That is 37, because 37 repeated 4 times here. So that mode of the given data we have a 37. Look at the question number 13 from practice set 7.5. In the following table, the information is given about the number of families. We have the second row number of families 15, 25, 5 and 5, and the number of siblings in the families less than 14 years of age. So one sibling exactly, number of families 15. Two siblings exactly whose age is less than 14 years, we have 25 such a families. 3 siblings whose age is less than 14 years, we have exactly 5 families, and 4 siblings we have number of families 5. So now we have to evaluate, that means find the mode of the data. So among the observation 1, 2, 3 and 4, which observation is repeated number of times? So that are the values of xi, ultimately number of siblings, and fi means the frequency, we have the number of families. So that 25 be the greatest number among all, 15, 25, 5 and 5. So here 2 is repeated, that means number of siblings are 2 in how many families? 25 families, and 25 be the maximum number over here, that means 2 is repeated 25 times. So the mode of the given data, maximum number of times repeated observation is 2, so the mode is 2. Look at the question number 14, practice set 7.5. Find the mode of the following data. We have the data is of the form marks 35, 36, 37, 38, 39 and 40. So those are the values of observations, that means the xi, and number of students we have exactly 9 students who has the marks obtained 35, 7 students exactly who obtained the marks 36, 9 students exactly who obtained the marks 37, 4 students who obtained the marks 38, again 4 students who obtained the marks 39, and exactly 2 students who obtained the marks 40. So those are the values of fi. Fi means the number of students. Now check which observation among 35, 36, 37, 38, 39 and 40 repeated maximum number of times. So we have exactly 9 and 9 be the greatest number among 9, 7, 9, 4, 4, 2. That means we may have here mode of the given data, it has 2 values because 35 and 37 repeated same number of times, and that should be the maximum number. So that mode is 35 and 37 for the given data. So here we have our practice set 7.5. Thank you.